Dear students, today we are going to discuss about vectors. You know that vectors are those physical quantities that requires a value which is called magnitude and a direction to be expressed. For example, velocity. Velocity is a vector quantity which is actually speed in a particular direction. You can think about other examples of vector like, for example, weight. Weight is a force which is directed toward the center of the earth. Alright? Displacement, the shortest distance between 2 points in a particular direction, so on and so forth. Here, we need to see that how to represent a vector, how we can add or subtract two vectors, what is negative of a vector, what are parallel vectors, and what is meant by multiplication of a vector by a scalar quantity. So, vector representation. Vector can be represented by a straight line. Okay, and there is a tail end of this vector and a arrowhead of that vector. You can name it, for example, AB. So this is a vector AB. You can also use small letters to represent the vectors. In that case, we can say that, for example, a vector A. Normally, this small letter is represented in bold in your book. So that is how you can represent a simple vector. The length of this line represents the magnitude, and this arrow represents the direction of the vector. Okay? If we have a vector of the same magnitude but in opposite direction, like that, so this will become vector BA, right? BA. So direction is changed. Therefore, initially it was represented by A, now it will be represented by negative A. So when we change the direction of a vector, the sign changes also. The sign of the vector also changes. So if this is a vector A in this direction, then that is a vector negative A in the opposite direction. Okay? Right, let's move to the next one, vector addition. Let us consider that we have two vectors. Let's say this is vector A in a particular direction, and then there is another vector. Let's say this is vector B in another direction. If we want to add these two vectors, what we need to do, we simply move this vector B and okay, I will redraw it. Basically, it's okay. Let's try it. I will move it here. Okay, that's it. So we will join the tail of vector B with the head of vector A. That is how you can add the vectors graphically. So result of these two vectors which are added together is known as resultant vectors. So this is our starting point and this is our end point. So that is our resultant vector, which is known as A plus B. Okay. Similarly, if you are asked to work out A minus B, so we know that if this is vector B, then that would be minus B. So A minus B is same as A add minus B. Okay. So you can then draw vector A, and then this is vector B. So join the tail of vector B to the head of vector A, like that. That is our vector B. Okay. And then this was our starting point, that is our finishing point. That will be our resultant vector, which is A minus B. Remember that in case of addition, A plus B will be same as B plus A. You can check this one yourself. But in case of subtraction, A minus B is not equal to B minus A. So these are two important results as far as vector addition is concerned. Then we have multiplication of a vector by a scalar. Scalar can be a number. So for example, if we have a vector A in a particular direction, and if we multiply this vector by 3, so what will happen? This vector, its magnitude will increase 3 times the original vector. Okay, so that is 3A, but direction remains the same. And you can see that both of these vectors are parallel vector, which is our next heading. You can see it here, parallel vectors. So that is when you multiply a vector by a number, that number will then cause an increase in the magnitude, may cause a decrease also in the magnitude of the vector. When I say decrease, so if you multiply vector A by half, so that will be the new vector, which is half the length of vector A, but still it is in the same direction. If you multiply a vector with a negative number, for example, if I multiply vector A by -3, so of course its length will increase 3 times the vector A, but at the same time its direction will be changed. So that is -3A. All right. Parallel vectors. So you can see, you have seen that here, when we multiply a vector by a scalar, the length of the vector may change, but the direction doesn't. Okay, so the point is, whenever we multiply a vector with a scalar quantity, say this is A and this is 2A, the length increases or may decrease, but the direction remains the same. So the vectors which are multiples of each other are always parallel vectors. They can be represented by same letter. For example, if this was A, so this will be also a multiple of A, and this will be also A, that is a multiple of A. Similarly, if you have a vector in the opposite direction, say this is -3A, still it remains parallel, but its direction will be changed. Okay, right? After this one, if you understand, and I'm sure you understood the topic, please start the